Hello, good morning, everyone. So, today we are going to start revision for week 6. We have revised week 5. Is there any doubt related to that?
Good morning, ma'am.
Good morning. Yeah. So, let's start with week 6. Fine.
Yes, ma'am.
Yes, ma'am.
So, let's say you have two random variable x and y. Okay. So, yeah, two random variable you have x and y.
My revision session is recorded, right?
Yes. So, you have when we have two random variables at that time we deal with the joint density, right? Density. Let's say these two random variables are continuous and now we are dealing with the we will deal with the joint density of continuous random variable. So we have seen that about two random variable. The first case was both discrete. At that time we were dealing with the PMFs of x and y, right? Then one discrete and one continuous, right? At that time, one
Yeah.
integral part was there and one summation part was there, right? Now both are continuous. Okay. So in real life problem, any of the following case can come into picture and we have to deal with that accordingly. So let's say both are continuous. So if your x and y are continuous random variable, then the denotation for joint density is this one, fxy. Is said to be joint density function if it satisfies some of the rules. The first one rule is it should be
Positive.
positive always, right?
Yes,
Non-negative
ma'am.
interval. And the second one is, yeah, anyone?
Integration in the support of x will be equal to 1.
In the support of x or what? We have
Range.
two random variables.
Yes, ma'am.
So only
Double
support of x.
integration of double integration of f of x comma y dot
Yeah,
dx dy is equal to 1.
yeah. So only support of x will not work. We need support of x and y, right?
Yes, ma'am.
So I dx dy it should be 1. That is what does it mean? When you add or when you consider all the possible events, then it should sum up to 1, right? Let's say negative infinity to positive infinity. Fine. So whatever the support is, we will take accordingly. So these are the some rules that we have to take care of when solving two continuous events associated with two continuous random variables. Fine. So there are many cases like we discussed in discrete. Here also we have many things that are depending on distribution of x and distribution of y, right? So let's say both are there are uh, two random variables x and y and their density function is given as like this. Fxy is equal to, let's say it's given as 1 when x is lying between 0 to 1 and y is also lying between 0 to 1 and 0 otherwise. So this is kind of one of the example where uh, x and y are two random variables following this distribution having density function like this. So do you remember what kind of thing it is?
Unit
Any
square.
idea? This is unit, yeah, unit square. How did you get to know that it's a unit square?
because it's
Because
bounds
the
an area.
function,
Because the bounds are between from 0 to 1 for both x and y. So ultimately, if we plot it on the paper on a graph, then we'll get a unit square only.
Okay, correct. So whenever you plot this type of things on real lines, let's say this one is for x, this one is for y. X is here somewhere, one here. Let's say somewhere one here. So what will be our targeted region? This one. So the point to show this one is, yeah, yeah. What might be the point to show this one? That whenever you have a two continuous random variable, now you will be dealing with the area of the like concerned area according to that, right? If two random variables are there, and see, any practical problem, we convert it into mathematical or statistical format, and then uh, we solve it according to our theorems and analysis, right? For that we need some pictorial things sometimes, like this one. In this one we converted our format into pictorial form, and now we will apply whatever needed and solve the corresponding. So, can you check whether this given PDF, sorry, density function is valid or not? Is it a valid
yes,
joint
ma'am,
density function?
valid.
Okay.
Yes, ma'am,
How
valid.
do we check it? So, yeah,
We will
Like
find
the
the
Greater
sum
integration
of
than
the
of
one.
0 to
probabilities.
1, 1 into
fx y,
dx dy.
yeah,
Range will be 0 to 1 for both.
yeah, dx dy.
Sorry, yes, 0 to 1.
Yeah, for x the range is 0 to 1, for y the range is
Same, ma'am.
0 to 1, right? So, yeah,
Function will be 1.
yeah, function is equal to 1 here. So when you integrate 1 dx, it's nothing but x, right? Equals 0 to 1 dy. So yeah, again, once you put the values, it's nothing but 1, right? So
Ma'am,
once,
is it necessary to check this every time?
no, I'm just I have written the density function, so I checked it.
Okay, ma'am.
Yeah, fine. So let's take some example based on that. Before taking example, let's take, can we find from this given data, can we find what is the probability that x is greater than y whenever your x and y are some distribution function, some random variables following this distribution? Can you find what is the probability that x is greater than y?
We should draw x equal to y. And
Yeah,
0.5.
okay. Just try to proceed it, how to do that. So whenever the question asks about this kind of things, x is greater than y, let's change it to x greater than twice y. Okay. Let's start with the x greater than y itself. So uh, we will draw the graph like x is equal to y. Let's plot
Yes,
the line.
ma'am.
Let's plot the line here. So sorry.
the opposite way.
Lower, yeah.
Yeah. So the line will be somewhere from here,
In the
right?
center. Yes.
45 degree above from x-axis.
Yeah.
And we
Fine.
will
This is
find the
x is equal
area
to
in below the line.
below the line or above the line.
Below, below.
Below
Below the
Okay.
line.
x greater
Fine.
than
Below
y.
the
This
Below the
So this
is
will be okay. Just change the color. Yeah. So
Half into 1 into 1.
okay, fine. Yes. So yeah, if this is a triangle, then what will do? Since it is a
Half
triangle,
into
right?
base into height. Yes, ma'am.
Yeah, we can
Half
use
into
directly
1
the
into 1.
formula for triangle, right?
yeah.
So that is half of the 1 into 1, that is 0.5. So
0.5.
Once you calculate probability x greater than y, can you just tell me quickly what is the probability that x less than y?
0.5.
Point
One
have
minus.
point
Yeah,
5.
directly 0.5. How did we get? So it's nothing but 1 minus probability x greater than y. That is equal to
Ma'am,
0.5. Yeah.
if there is a question that probability of x greater than 2y or something, then
Okay, let's check that. Probability x greater than twice y, right?
2y. Yes, ma'am.
Okay. So what we will do, we will draw this line x is equal to twice y. How that line will be?
Same like this.
Only the this one will change. Okay, let me draw. Yeah, the slope of the line will change, no?
Yes, ma'am.
Yes.
Yes, ma'am.
And then how will you calculate? Yeah, try that. This is 1 x and here y. Fine. We want x greater than twice y will be when x
Y
is
equal to
equal
x
to
by 2.
Towards
1,
the
y is equal to,
x-axis. Towards the
Y is equal
x-axis.
to x by 2.
yeah. So this generally we directly put this initial point and last point. When x is equal to 0, y is 0. When x is 1, y is x by 2, right? So that will be like this. So what is the area that x is greater than twice y?
Down area. Downside area.
Below the line.
Below the line. Fine. This one is your
Ma'am, that
area.
is the confusion, ma'am. Can you tell how to decide whether it is below the line or
Ma'am,
above the line?
Ma'am, it's very simple.
See, x is
calculate
greater
the
than twice
area.
y. You just, yeah.
Calculate the area of rectangle and minus the area of triangle.
You can directly use the area of triangle also. No need to calculate the area of triangle also. Rectangle. You can directly use.
Yes.
Okay.
But
So
ma'am,
just,
how do we find that the vertical of the what means the height of the triangle is what?
isn't it height?
Yeah, height is 0.5, right?
Ah, this
Half
one
of
is
the
1.
1.
How?
Yeah.
Yes, yes.
This is x is equal to 1 and this line is x is equal to twice y. So put x is equal to 1, you get y is equal to 1 by 2. So this point is nothing but 1 comma 1 by 2. Yeah. So how to check whether x is greater than twice y or not? You just check any point. Let's say this one. Here your coordinates are what? 1 comma 0, right? What about at this point?
1 comma 1.
At 1 comma 1. So your x is 1, y is 1. Just check whether your x is greater than twice y. When you put twice y, it becomes 2, right?
Yes,
So
ma'am.
your x is equal to 1, y is equal to 2. So this part is not the required one.
Okay,
Here,
it's
let's
x one.
say,
Okay.
yeah, like that one. You just check at
Thank
some
you.
points. Yeah. Okay. So x is equal to x greater than twice y. It is nothing but the area of this triangle. Let's say A, B,
Ma'am,
C. Yeah.
you wrote the coordinate 1, comma 2, but yeah,
No,
it's
it's
1
1 comma
comma
1
1
by
by
2.
2, right?
It's 1 by 2. Yeah.
Okay.
It's
You
1
just
comma
wrote
1 by 2.
you just erased it. That's-
That was for x is equal to twice y, where you multiply this 1 by 2 that I was indicating. Okay. So x greater or equal to twice y, how will you check it? So nothing but the area of triangle ABC, right? That
That's
is
right.
nothing but 1 by 2 into half into 1, right? So it's 1 by 4. Okay.
Yes, ma'am.
What if, okay, fine. Let's check it. So this was all about, so here in this particular case, question was easy. We can make it simply harder side by just changing these values. You know why you were able to say that this probability is nothing but the area of this region. Probability x greater than twice y was the area of this region. You were not considering the whole area. See, uh, initially when we start probability, What is the definition of probability?
Favorable outcome upon total outcome.
Right. So here, what you are calculating in this till we have solved some 3
Area
questions,
of
right? We
triangle.
are just directly calculating area of favorable outcomes, right? Probability x greater than y is nothing but your area of favorable outcomes, right? These are your favorable outcomes, isn't
Yes,
it?
ma'am. Yes, ma'am.
So why are you not considering total outcome here?
Because it is 1, ma'am.
Yeah, because it was a standard uniform distribution. So that's why uh, whenever we change it to from uniform to non-uniform, not I should not say non-uniform, just slightly change. I will slightly change the question and see what will happen.
Ma'am,
Favorable, yeah.
ma'am, this in this last few example, wherein
Mhm.
you are finding x greater than y, x less than equal to y, or x greater than 2y,
Mhm.
these are all CDF or PDF. These are all PDF, right? We are dealing in a range, right?
Yeah.
Correct, no? Or is it
Yes. Yes.
PDF?
Yes. Yes. It's PDF.
Okay, okay, okay.
But even see, whenever there are two random variables, we will say it a joint density function, not PDF. PDF is what probability density function of a particular random variable. Here we are dealing with the two random variables, so it is about the joint density, because when we are considering these points, that means x is taking let's say value 1 and y is taking value 0. X is taking value 0, y is taking value 0. This kind of probabilities we are considering. So we when we are whenever we deal with the two or more random variables, it's about joint density. So proper word should be that one.
Okay, so it
Okay,
is not CDF, PDF, but it is joint
joint
density.
density, yeah.
Mhm. Okay.
Fine. So let's change a little bit. If I say x and y are some random variable which are uniformly distributed in the region, let's say let us say 1 to 2 cross 3 to 5, no, 3 to 5. Let us take it from 0 to 2 cross 1 to. Then how will you proceed it? Any idea? So just one hint here, that whenever
First, we will calculate the area of the favorable region and divided upon the total area of the region.
yeah. So the thing is, whenever your x and y are random variables which follow some uniform distribution, then its PDF that then its joint density, that is f of xy, is given by 1 upon area of the region. Area of, let's say this one is your D. Area of D,
To
1
square.
upon, yeah, for the range whenever xy is belonging to this region D and 0 otherwise.
Ma'am, this only works for uniform distribution.
Yes, yes. Here we should be confirmed with this xy, this joint density, joint distribution is following uniform distribution. Once it's uniform, you can have its PD, joint density like this one, 1 upon area of D. Generally, we take it as a modulus one. Fine. So, if our D is set like x comma y, such that your x is lying between 0 to and y is 0 to sorry 1 to 2, right? Then just check what is the probability that x is greater than y plus 2. Okay, this is your question. Did you do you guys understood what I am asking?
Yes, ma'am.
Yes, ma'am.
So whenever this kind of question is there, our first target is to draw this kind of figure. So let's find it.
Ma'am,
Yeah.
we will take the minimum value of x coordinates and the maximum of y, and then draw the whole figure.
Hmm. Sorry, I didn't understand your question.
Here x belongs to 0 to 2 and y belongs to 1 to 2.
Hmm.
So uh, I don't know exactly how to draw it.
Okay, I'm just telling. This is x. This is your y. Let's
First, we
say
will
point
draw the
7.
line x is equal to y plus 2.
Yeah.
Will
So
this probability be zero, ma'am?
let's shake it. Okay. So our graph is okay. So x is lying between 0 to 2. So this is our x range. What about y? Y is ranging between 1 to 2. That means our area is which one?
Ma'am, x was between 0 to 2.
Yeah, 0 to 2. So
X equal to 0, y equal to 2.
1 to 2, right?
Yes, ma'am.
So which is our region? Anyone?
The upper
With
rectangle.
This upper
Middle one.
Upper
rectangle,
rectangle.
Yes.
Upper
right?
question, yeah.
Yeah, this one is our required region. So let's name it A, B, C, D. Fine. And what are the coordinates for B? It's 2 comma 1, right? And here 2 comma 2. Fine. Okay, so this is our required.
Ma'am,
Yeah,
ma'am, how it can be the upper rectangle? Can you
yeah.
explain?
So you
Because
want, see, 0 to 2 was our x was lying between 0 to 2. Fine. So I just
yes,
marked here a dotted line at 2, right? Because 0 is there. And then we have given that y is also belonging to 1 comma 2, right? So just mark it. Now you have to intersect the portion where x should lie between 0 to 2 and y should lie between 1 to 2. So which one is the region? So if I take any point here, so here from in the triangle ABCD, if I take any point here, any point lying inside, will be the point where x is lying between 0 to 2, right? And y is in between 1 to 2. So in that way, we decide that this region is our required region.
ma'am, can we see
if we take
this?
a point 2 comma 2, then how it will be possible? 2
2
is not.
comma 2, why not possible? See, both are closed intervals, so both are included, right?
Ma'am, if we take it as a perpendicular rectangle, I think that would be the correct shape, because if you take any region from 1 to 0, then it will be not possible for y range, I think.
What?
If you take any point from 1 to 0 in y range,
1
then
to 0, yeah.
then there will be no point for y, because there is a blank space now, because the x range is starting from 1 to 2. We can't
Yeah, yeah,
accept.
yeah. But
Ma'am,
we are not discussing that. I am explaining why we took this region. Yes.
ma'am, I think it would be easier if we think like this. We will shade the whole part 0 to 2, x equal to 0 to x equal to 2. The whole region we will shade in a color, and we will take another color for y equal to 1 to y equal to 2. Then
Yeah,
If we
but
there will
take
I
be a
a
think
geometry change.
that is done in the lectures, right?
point 1 2 comma 2, then 2 is less than 4, na? Not greater than, but in the question says greater
Just a
than
minute.
by
You
2.
are just going to directly to deal with the probabilities, right? Just a minute. Someone has asked about the how to decide region. So those who have solved the question, just hold on it. Okay.
Ma'am, can we say this as support of x comma y?
Yeah, this is support of x comma y. So, okay, did you got how to decide the region or so whenever this kind of things are there, you have some range for x and let's say some range for y. So 0 to 2 we have given, right? X is 0 to 2. That means whenever you decide your region, your values of X should not cross this boundary, right? Isn't it? Your region
Ma'am.
should be this one. Yes.
Ma'am, X is 0 to 2 or Y is 0 to 2?
X is 0 to 2.
Y1
Oh,
to 2.
okay.
Y
Okay.
1 to 2. So
Okay.
just
Now I got it.
yeah. And now draw the 1 to 2. That means Y should not exceed this X boundary, and this boundary is given by Y. So the required region is this one. Okay, fine. So this is our area, and now whenever we have two random variables, the first task is to determine what's our joint density. Please mute yourself if you are not speaking. So let's say joint density. So as we discussed, as X and Y are following uniform distribution over D, our joint density Fxy is given as 1 upon area of D, right? So what is area of D?
It's,
units.
1 into 2.
2.
Yeah, it's the area of rectangle. So here area of D is 2 into 1. So it's 2. So our Fxy is
1 by 2.
1 by 2 whenever your xy is belonging to D. D is your support region, is it?
Yes, ma'am.
Okay. So now we are interested in to calculate probability x greater than y plus 2, right? X greater than y plus 2. So first draw a line x is equal to y plus 2. Okay. So x greater than y plus 2. So x is equal to y plus 2. How will it look whenever x, okay, let's say y is 0, then x is 2, right? Okay, the line will be from here onwards, right? So what is the probability? Yeah.
0, ma'am.
Okay, fine. Why it is 0? Because
Because
the
there
region,
is no intersection between the region required and the
yeah,
original support.
these things can also happen that we can have some region where it is not intersecting with our region, right? So our x greater than y plus 2 is this area which is not intersecting with our required region. So the probability that x is greater than y plus 2 is 0, right? Is it fine?
Yes, ma'am.
Okay. What if I ask what is the probability that x is less or equal to y plus 2 then?
1.
It will be 1.
Then it will be 1.
Is it 1?
1 minus 0 equal to 1.
Yeah, it's
Ma'am, how did you go to that point directly, like x plus y is equal to 2? Yeah, that region.
this one.
Yeah.
Okay. So whenever we have equation of line, so the easiest thing to do is just plot 2 points. Any 2 points. Let's say I took y is equal to 0. So my x is equal to 2. So this 0 comma 2 is here, and just take any other point and plot it.
Ma'am, but the range of y is between 1 and 2 now?
Yeah, it is 1 and 2 for our region D. But when you are drawing this line, there is no restriction, right? So when y is equal to 1, your x should be 3.
Yes.
So
Like
here
that.
might be some 3. Yeah.
Ma'am,
So, yeah.
for your second question, can we say that this whole support area is taken under
Yes.
probability will 1?
Yes. Whenever we say x less or equal to y plus 2, what will be the region for x less or equal to y plus 2? Above this line, right?
Yes, ma'am. Whole
and
support is coming under
yeah,
that, so we
yeah,
can say
yeah,
about this one.
above this line, whole line. So our region is intersecting as a whole, so probability will be 1. Fine.
Ma'am, just
Will
one.
be a 1 or 1 upon 1 by.
Yeah, ma'am, one doubt on this. How do we consider the shaded region when we are taking less than or greater? Can you please explain that once again?
Like how to check whether it's less or equal to, like that?
Yeah, how do we tell that when we say less than, we take the lower region below that line? How do we take that above region when it's greater than?
Let's say your graph is like y is equal to x square, that means parabola, okay? Y is equal to x square, okay? We are drawing that. So this might be your region, right? Something like this, right? Now if I ask you what is the region y greater than x square, what will you do? This line is plotting y is equal to x square. We are interested to find out which region will give you y greater than x square. How will you proceed? You just check. So all these points in 2 dimension are the points of x comma y format, right?
Yeah.
So if all the points are in x comma y format, then if I select any random point here, please mute yourself because it will disturb others. So every point here is some xy format. So let's say I have picked up some point here. What might be the coordinates here? Let's say this might be some x comma y, let's say. Okay, can you just check me which x is greater than here or y is greater than here at this dotted point?
Y will be greater.
Y will be greater, right? By observing like this. So, okay, x is some around 1, it is, right? Around 1 or 1 by 2, let's say. Yeah.
We can simply say that for x equal to 1, we can take many values which are greater than or equal to 1. It can be 1, it can be 2, it can be 3, any other value which is greater than 1, right? 1 and other values which are greater than 1. So
Yeah.
the whole, yeah.
Fine. So so you decided, you only told me that at this portion, like whenever I am observing above this line, my x is what? Less than y, isn't it?
Yeah.
So let me just one more thing. If I ask you, what will be here? Like if I take any random point, let's say here point A and point B. What about what are the nature of x and y? Which one is greater there?
Ma'am,
Y will be greater.
Your y is greater always. So and just for clarification again, if I take any
Ma'am,
point here, yeah.
it would be easier if you explain the example x equal to y. You can simply show.
Let's just continue with it. Just a minute.
Okay, ma'am.
So just take any point outside the curve. Let's say this one. Let's say this point C. It's almost looking like equal. Let's say this point C. What do you say about this point now?
X is greater than y.
X is always. So
negative.
just to confirm that, I draw like that. Okay, let's take this point D. What about this point D? Which one is
X
greater?
is
X
greater.
Is greater than y.
So like that only we decide which portion is greater or less. So my question was, if I want y greater than x square, which one will be your region?
Above that curve.
The region inside the
Above that curve. So there is one thing, above the curve and below the curve, the nature will be same if your curve is either convex or concave. Okay, so that's another thing. Let's say if now this is your region for y is equal to x, y greater than x square, right? Y is greater than x square. This is this red colored part is y greater than x square, right? What about this part outside, like below this curve?
less than or equal to.
Okay. Now, just to check whether you guys understood or not, if I tell you, x square plus y, no. Just tell me if I want to check whether x plus y is greater than 3 or not, what will be my vision? Okay, just take it less or equal to 3.
First, we
We'll
draw the
draw
line.
a graph of x is equal to y minus 3 or 3
Okay.
minus 5.
Or we
Fine.
can simply plot the line x plus y equal to 3.
So it will be something like this one.
Yes, ma'am.
At 3, 0 and 0, 3, right? We'll have the coordinates.
Yeah. Something like this. X plus y
Yes, ma'am.
is equal to 3. Now, which one is less or equal to 3 part?
We will shade towards origin 0, 0.
Origin, the lesser part is this.
Towards the origin, what about this part? Why are you not considering this part?
All those are considered.
Means from 3 to minus infinity.
Yeah. So this is your x plus y less or equal to 3. Like that only we decide whether it's less or
Yeah.
equal to or greater. Okay, fine.
Yes, friends.
Yeah.
Clear, ma'am. Thanks, ma'am.
Again, if I ask in this same graph, I want to find x plus y less or equal to 3 and x is greater than y. What will be your answer?
Means it will just a simple straight line from origin.
So just draw the line x is equal to y like that. And what is greater than y? X is greater than y. That means below the.
It will be the below region.
Yeah.
It will be the below region.
Shading downwards.
Yes.
So
It will be
which
the
is
below region.
so this one will be
Yes.
x greater than y. But I
Yes.
want both. I
The
want
triangle-
both the conditions.
The
That
triangular
means
region. The
not triangular.
Triangular
Yeah,
region.
triangular
Yes.
you can say.
Below
But
region.
both of this, right?
Yeah, that means the
We have to
intersection
consider.
intersection point.
Because we have not bounded that I want my x and y to be positive only, right?
Yeah.
So that's why this green part will be our intersection part. Fine. I hope this is clear. So
Yeah, ma'am.
okay. What about the probability x less than 3y in this particular question when we are dealing with this one? Okay. So x and y are some uniform distribution following over the region D, and I want to find what is the probability that x is greater than, not greater than, less than 3y.
Ma'am,
Yeah.
what will be the graph of x greater than when y we will take 2?
When you take y is equal to 2. Okay. So you just try. This is your x, this is your y is equal to 2, you are fixing, right? This is y is equal to 2. You want what now?
In the equation x equals to y plus 2 we are taking. So if you take x, y equals to 2, so x will be 4. In the above
Can you
graph.
please repeat?
In the above graph, when we are taking x equals to y plus 2.
Just a minute. It's not clear at all.
In the previous question, ma'am. Hello.
This one?
No.
Okay, this one, yeah.
Yeah, this one.
Mm-hmm.
When we'll take y equals to, when we'll take y equals to 2, what will be the graph? And x
Y
will
is
be
equal to?
2. So x will be 4.
Yeah.
When we plot, what will be the graph? It will intersect, no?
How it will intersect? Your x range of x is 0, 2 only.
But
X
it will be
is
0
equal to
and 0.
X is equal to 4, no? It
Yeah.
will not intersect. Your graph is stopping here only. Your x cannot take value 2 in this particular region D.
Ma'am, that
So that will be 0.
Yeah.
Ma'am, that given problem, it is answer is 1, right? Or because it is
For
up
this
to
one,
yeah.
just to hold it. What about others? X is less than 3y. So the region here is this one, right? So x is less than 3y. So how will it look like? X less than 3y, x is equal to 3y we want to put, right? X is equal to 0, y is 0. X1, y is equal to 3. No, sorry. X is equal to 3y. Y is equal to 1, your x is equal to 3. Okay. Again, my bad. Yeah, it will be 1. Because the line will be, let's draw somewhere here.
But will be this will be the intersection of that line, no?
How?
This is the only condition, or that line is also considered now for boundaries? Previous line.
So this is our region D, right? This is 2, this is 1, 1 and 2, right? So what about x is equal to 3y line?
Only for this line, whole region is coming under that.
Yeah. So x, y is equal to 1, right? So the line will be like, line will be like this, right?
Yes,
like this, right? X is equal to 3y.
Yes.
We want x less than 3y.
Above region.
The above region, right? And it will intersect with the whole D, right?
Yes.
Isn't it? Everyone is getting or not?
Yes, ma'am.
So the probability will be 1. Okay, let me change again. Probability x is equal to, not equals to. X less than 1 by 3, 1 by 5y. Then or if let's just make it easy, x less than y. Okay. First calculate this, then calculate this y by 5. X greater than y by 5.
So in the first part, x less than y, it is that.
Okay, x less than y, we will just draw the line x is equal to y, right?
Yeah, half portion, upper portion
that's
of
also
the.
one.
That is half portion, upper portion of the triangle.
Yeah, then
it is 1 by half. It is half.
okay, 1 by 2, is it fine?
Yeah, correct.
Okay, there is one option, 1 by 2. Any other answer you got?
For the question, probability x less than y, is it, ma'am?
Yeah.
Its answer is 1.
Okay, another answer 1. Anything else?
3 by 4, man.
3 by 4. Anything else?
Three by 4, I think.
We should
Okay.
integrate.
Okay. So x less than
We
y,
will
we
first
are
calculate the
interested.
area of rectangle.
Yeah,
And
this is
minus
area
the
of
area
rectangle
of
D.
triangle.
Okay. Just a minute, wait. Now, let's say. So this is region D. And now we are interested x less than y. That means which one part? Which part? Above or below? Above one. So the required one is we are interested in finding out this probability, right?
2 minus half.
Yes, ma'am.
What it is?
2 minus half.
Yeah, that is also fine. 2 minus half, you can do it, or anything
Divided
else.
by 2.
3 by 2, ma'am.
1.5.
Divided by 2.
So
3 by 4.
probability x greater than y. The area of this whole part is D. But when we consider this green region, area of green part right? Green region divided by what it should be?
Complete D.
Area of D. Fine.
How do you find the area of green region?
Yeah. So area of green region will be what?
2 minus half.
Yeah.
Area of rectangle minus area of triangle.
Yeah, that is
No,
also.
probability of x less than y, no? Greater.
Area of rectangle plus area of square.
X is?
Less than.
Yeah.
Probability of x.
Yeah. Yes. Thanks. Okay. So it's nothing but the area of D minus, you can just easily find out this area. Let's say this white colored part. So this is a rectangle whose height and base both are 1, right? So this area is
1.
1. How
Half.
it is 1, man?
Half,
It's a
man.
1 by 2
No.
into 1 into 1.
Half. Sorry, half.
So that area of A, let's say this is A. So yeah, it is 2 minus 1 by 2. That is nothing but 3 by 2. So probability x less than y is what?
And 3 by 2, not 3 by 2.
3 by 2. Sorry. So the area of x less than y is nothing but 3 by 2 divided by the area of 2 is 3 by 4. Answer is 3 by 4. Okay. So whenever you do not have, whenever we do not have uniform region, that means uniform area, standard square, at that time we have to divide the area of the D. Why we need to divide it by area of D? Because the general law of probability, right? That is favorable outcome divided by total outcome, right? This formula, we are using only this formula, nothing new sciences here. Okay. What about probability x greater or equal to y by 5? So will you try this? And this is the homework. Okay, let's try it. So after this joint density, whenever there is a concept of joint density, there is one more thing.
The problem you are giving it x greater than 5y, is it?
Yeah.
Okay.
Yeah. Joint density. So whenever there is a joint density, there are two more terms that we always take care of, because they will help us to know about the whole distribution. Because sometimes if we know the, though sometimes let's say we know the marginal density. So these two terms are nothing but the marginal density and conditional probability, right? Because it may happen that sometimes we know about the conditional distribution and marginal distribution, and then using these two we can use we can find about the joint one. So what is marginal distribution then? So marginal is whenever we are interested to find out the distribution function of one random variable, whenever we are given with the joint density, let's say fxy, and we are interested in finding out the density or probability density function of only x or only y. That means individual probability out of this joint density. Whenever we are interested to find out, let's say, individual distribution of x, but the information is available for joint density only, then we need to then we can find out the marginal density. What is marginal density? Individual probability of your random variables. Okay, so here there are two random variables x and y, and we are given with the joint density. Then what is the marginal density of x? So whenever
integrate over fxy of xy dy, and range will be the dy.
Yeah, but why it is so? Because we are interested in finding out the marginal density of x. That means how the distribution of x is varying. So as it is the joint event, we have to fix our x, as we are interested in finding out the marginal density of x. So we will fix x and allow y to vary in whatever the limits of y are. Let's say I will say it support let's say y is equal to negative infinity to positive infinity. Fine, on safer side I am writing, and integrate over y. So this will vary, or like take all the possible values of y and fix x, and in this way we will be able to find out the probability or distribution of x alone. So this is called as marginal distribution or marginal density. Fine. Similarly, there is another random variable y. For y, the marginal density will be just fix your y and vary your x over the whole region. That's it. Okay. So generally, if joint density is given, then obviously if you know the joint density, then you can find out marginal density, right? See, from the formula itself, it is easy to observe that once you know the joint density, you will be able to find out the marginal density. Now we will ask.
I have a doubt.
Yeah.
Ma'am, I have doubt in the. It is also in the week 5 content then marginal density. Then I became confused in between which formula I can use.
So have you joined this class from the beginning itself, or
Yes,
in the
ma'am.
middle you joined? So initially only I told you there are whenever there is a joint density concept, we look at the random variable, how it is. If it is a both one discrete, one continuous, and both continuous. Today we are discussing, yeah, which one we are discussing today?
Both continuous.
Both continuous. So whenever your both random variables are continuous, you have to go with this. If your one random variable is discrete and one is continuous, then according to whatever we studied there in week 5, right? Okay. So that's why only I always focus on whether, just check if joint density is given to you. First, your task is to check what kind of distribution x is and what kind of y is. Whenever I see kind of, that means just check, is it discrete or continuous? Okay. So there are when we talk about joint density, there are 3 formats. Both may be discrete, then you have to follow what we have studied in week 2, week 3 stuff, or maybe around week 1. I do not remember exactly which week it was, but in quiz 1 we have learned that both discrete, then follow that. If both like one of the random variable is discrete and one of is continuous, then follow that we studied in week 5. If both continuous, then follow this. Okay. Okay, so you can make notes regarding this, that what stuff where to use. Okay.
Yeah, ma'am.
So here.
In one of the lectures, in the case of discrete random variable, no?
Mm-hmm.
Sir has made a statement that summation over everything you don't want. Can we relate it to that?
Yeah, this is also the same thing. Summation everywhere that you don't want.
Yes.
So
it is same thing, integration over everything that we don't want.
Exactly. So do you know that integration is nothing but the kind of summation?
Yes, ma'am. Yes.
Riemann integration, if you might have studied somewhere, then there it has discussed that the summation of very, very, very small interval is nothing but the integration. Okay. So here also we are doing that thing. If you want to find the marginal density of x, then integrate over everything that you don't want, that is y. Okay.
Yes.
The same thing. So and now the question will arise, if you have a joint density, what is the need of marginal density, right? So whenever you know the joint, you can find out marginal. You have learned something about, you may have seen questions like x and y are independent random variables, right? Have you heard this kind of thing?
Yes, yes.
Yes, ma'am.
And
Yes,
you
ma'am.
know what liberty this independence gives, right? Like there are so many theorems and so many like useful things
Yes.
that will happen once you know that your x and y random variables are independent. So from joint density, do you know how to check from joint and marginal? Do you know how to check whether your random variables are dependent or independent?
Ma'am, we can check if the joint density is equal to product of marginals.
Yeah. So that is the thing. You have a joint density, so you can find out fx of x, that means marginal density of x and y, and then just check whether the product of this marginal is equal to your joint. If it is, then that implies x and y are independent random variable. Okay, fine. Independent random variables, fine.
Yes, ma'am.
Once you know x and y are independent, we know that the variance covariance will 0, and there are a lot of more things that we have learned. Okay, so now the okay, so let's check with one example how to calculate marginal, and simultaneously check also whether they are independent or not. Okay, is it fine if we do questions
Ma'am,
like
apart from this, what is the other use of marginal?
yeah, apart from this, you can find out what are the distribution your x is following. Sometimes this is also important. See, these are the tools that you are learning now. Then when you work with the real data, then you have to perform some prediction or estimation kind of things, right? At that time, this will help you. Once you know the distribution of x, you can make something, some assumption, some prediction about x and y, whatever it is. Okay, so these are
Yes.
tools as of now. Okay, so let's check with one example. And if some conditional kind of things is also given to you at that time, also this marginal things will help you. Okay, we can continue with this example also. Yeah, when your region D is like this. If your region D is looking like this, then just check whether your x and y are dependent, independent, or whatever it is. Your region is D and x and y are following uniform distribution over this region D. Are they independent? Did you get my question? If x and y are two random variables which are following uniform distribution over this region D, that is 0, 2, cross 1, 2, then check whether they are independent or not.
They are independent.
They are independent. Okay. What is the marginal
Yes,
then?
ma'am.
Okay.
Marginal of x is 1 and marginal of y is 1 by 2.
Okay. Let's say fx of x we are calculating. So, okay, first let me just write what is joint distribution. Fx comma y is what? 1 by 2, right?
1 by 2.
Whenever xy is in D and 0 otherwise. Okay. So fx of x, that is marginal density of x, is what? Integral over y fxy dy, right? So what will be the integral limits for y?
1 to
1 to 2 and integral
1
over
to 2.
1 by 2. Yeah. So it's very easy there.
Half.
1 by 2, 2 minus 1, right? That is 1 by 2. Fine. And what about fy of y? That will be integral over x fxy dx.
Dx.
So The integral limits for x is 0 to 2 and 1 by
Function
2.
is half.
Yeah.
1.
So it's
So
1 by 2 minus 0, that is 1. Okay. So yeah, our fxy is nothing but the product of marginal densities fx of x and fy of y. Okay. So this was one of the easy question where you will be able to find out these things directly by integrating.
Ma'am, or
Okay.
maybe graph also you can find. No?
Yeah.
From
Yeah.
graph also you can find, I think so.
From
Directly
graph.
from the graph.
Yeah,
Yes.
from graph, how you can find out by seeing the graph?
Yeah. I'm taking one example related to that.
How do we get that f of x, fx comma y equal to 1 by 2? How we got that?
Sorry, what? fxy?
Equal to 1 by 2 for x comma y belongs to D. How do we get that?
How do we did? Have you attended the lecture from there or what missed in between? See here, we told na if x and y are uniform over D,
Yeah,
then
got it. Got it.
yeah.
Sorry.
Ma'am, in general, like if the graph is in the same region and if it is homogeneous, I mean uniformly uniform shape, then it is independent, right? But if the area is split, then it is not independent most of the time, right? I mean, or is it not generalized that way?
Yeah, we can't.
Okay.
Okay. So let me
Ma'am,
just take yeah.
visualizing the graph, can we make any statement whether the fx and fy are independent or dependent?
No. Because when it comes to continuous kind of things, that kind of thing, I don't think we can generalize. See, the graph is looking like this, right? The rectangle, isn't it? For this particular, if we consider, then the figure is nothing but this rectangle.
Yes.
Now, as we do not know about the distribution, sometimes that you will learn in, I guess, week 9 onwards when estimation things come there. Sometimes if two random variables are like that, their distribution will show something that you can predict whether they are independent or not.
Means
But
some guess, not exactly.
not exact, yeah. That is at all that, yeah, we have to go like this only. Okay. So there is one example where I think you need to take the exam. You have to take the help of the graph. So I was looking for that. Yeah. So in this particular example, you are not looking at the graph at all, right? In this particular example, see, this was
I
the
tried through
easiest.
graph,
Yeah,
ma'am.
this was the easiest question where you can directly go through the values. Why? Because you know the range of y directly, 1 comma 2, 0 comma 2. Now every time the situation will not be like that. If I switch a question little bit, at that time you have to look at the graph. Even though in this particular, let me just check it. So our graph is something like this, right? Oh, it's not looking like a rectangle, but just consider it. Okay, so our region D is here like this only, and when we are integrating for this fx of x, you can directly even check from the region that the limits of y are 1 comma 2. So let me just take one example where you have to look at the graph and check what will be the limits. Like whenever we calculate the marginal density, the main task or main challenge is to find what are the limits of y or what are the limits of x. So for that, I'm just leveling up whether you can check it or not. Okay, just try it. Let's say x is following some exponential distribution with 2. and y is exponential with some random with some exponential 3. Fine. And if I ask you, they are forming the joint density, they are the random variable together, and are independent also. Independent random variable. And then if I ask you what is their joint density, can you will you be able to find out that? Find joint density of them?
Multiplication of both the marginals.
Yeah. Okay, just check it. And what will be the probability that x is greater than twice y? Okay. So you just told that multiplication of marginal density, but how will you calculate the marginal density itself?
Ma'am, we know the formula for that.
For what? Marginal
Lambda into e
density,
to power
right?
minus
For
lambda.
exponential distribution, we know the formula of x.
Fx is equal to lambda into
E to the power minus lambda.
Okay.
So that will happen for both of them.
So you are using the distribution of x, right, to
Yes.
find out the marginal density. Okay, fine. But that's correct. But give me the valid reason. Why can you take that as a marginal density?
Ma'am, because that's what marginal density means, right?
No.
Distribution of a random variable.
Yeah. Yes. Correct. Marginal density. See, marginal density is what? That is actually correct reason. Marginal density means the distribution of a random variable x itself or a y itself, but it is given directly. That means there are your marginal densities. Fine. So fx of x, we know that. What is it? Fx of x is
2 into e to the power minus 2x.
2 into e to the power minus twice x. Whenever, yeah, what will be the
X greater than 0.
greater than 0? And what is the marginal density for y?
3 into e to the power
3
minus
into
3
e
y.
power minus 3y. Y is greater than 0. Fine. Now, so fxy is what? Just a product, right?
Ma'am, what
Xx
is the
of
formula
fx.
of exponential distribution? I forgot.
What is the formula for exponential distribution?
Yes, yes.
Wow. Lambda into e to the power minus.
Minus lambda x.
Okay, okay. Mm-hmm.
That's like if it is a revision session, then the best way is to revise first yourself and then
Yeah, yeah. Okay, okay.
like okay, fine. Fxy of x comma y. So it will be direct product of fx of x and fy of y. Why we are able to do this?
Because they are independent.
Yeah, because x and y are independent. Okay. So yeah, it will be 6 into e to the power minus 5x. Is it fine?
Ma'am, suppose they were not independent, then it would have been very difficult to find the joint distribution. Right?
Exactly. Yeah.
Ma'am, why 5x? E to the power minus 2x into e to the power minus 3y, right?
Sorry, yeah.
Ma'am, is it mentioned it is independent? X and Y are independent?
Yes, are independent random variable.
Okay, okay.
Okay. So yeah, it will be minus 2x minus 3y. Okay. So this is our joint density. Or for simplicity, you can write it like this also. That is also fine. Whatever you are comfortable with, that is fine. Okay. So this is joint density, and now we are interested in finding out the probability x greater than twice y.
Ma'am, if they are independent, then how we'll find?
What?
If x and y are dependent, then how can we find the joint density?
Then for this particular course, it will be given to you. Okay. And that will be something more you have to learn for that. But for
Ma'am,
this
but in
particular,
real life, it won't be given, right?
yeah. So for that you have to study more subjects, right? More courses.
Okay, ma'am.
X greater than twice y. So yeah, how to proceed then? So now there is yeah.
We'll draw the line x is equal to 2y then.
Then yes. What?
And after that, the lower triangular means the lower region we have to find.
Okay, let's say this is x is equal to y. So x is equal to twice y will be somewhere like this, right? X is equal to twice y.
Ma'am, we also need to know the graph of e raised to minus of 2x plus 3y, right?
Is it needed?
No.
It's not needed. Why it is not needed? Because we know that the range of x and range of y, x is greater
Integrate
than
in the
0,
range.
x is y is greater than 0. That's it. We know that graph will be lying in this first quadrant of the real whatever we so the graph is, okay?
Only we need to indicate that joint, ma'am, in the range of this line.
Yeah.
Below for that. Okay.
Okay, ma'am. Okay.
Ma'am, now the limits will go to infinity.
Yeah. So that's what that's why I took this example. Here we need to look at the graph. So you do you know what how the graph of e power minus x looks like? It's like something decreasing, right? Like this. You might have seen that,
Yes, ma'am.
right? This kind of decaying graph. That means your e power minus 2x and minus 3y are obviously going to come in this region. So x, what we need, x greater than twice y. That means this region, right? This whole region is our required region. And now we are interested in finding out the probability of this thing. How to proceed then? Yeah, anyone?
Integrate in the range, ma'am, 0 to x by 2.
Yeah. This is x. Yeah. Okay. This is x greater or equal x greater or equal to 2y is our this region. Now we know probability density density function of this, and to calculate the probability x greater than twice y. So area of this part is our required one, right? How to do that? So nothing much, just double integration. Is it fine? So probability that x greater than twice y is what? Integral over y. Yeah, how will you integrate? So
0
now
to infinity.
there are
0 to infinity and x to x by 2.
0 to x by 2.
when you say 0 to infinity, the limits are of what? X or y?
X.
Y.
For x.
Sorry, x.
These are the limits for
X.
x. Okay, 0 to infinity. And what will be the y is equal to?
0 to x by 2.
0 to y by 2.
To x by 2, man.
X by 2.
0 to x by 2.
Yeah.
And integrate over fxy.
dy dx.
dy dx. Okay. So what have you done is you are ranging x from 0 to infinity, fine, and ranging y from the 0 to x by 2. That means you might have taken this strip, right? Vertical strip.
Yes.
Okay, fine. So for this particular thing only, I took this example that you have to consider this kind of thing. 0 to the limits of y are y is equal to x by 2, and just strip it, swipe it from left to right. That will cover your whole region. Yeah. So you might have integrated it. So integral 0 to infinity y2, sorry, 0 to x by 2, and 6 into e power minus twice x e to the power minus 3y, right?
Ma'am, suppose it
dy.
was greater, then what would be the limits of y?
Yeah, if it is greater than, then the limit will be
Y by 2 to infinity.
start from y
X
by
by
2.
2.
Yeah, your strip will be start from these things, right?
Right? To infinity, right?
Yes. So it will be y is equal to x by 2 to infinity. Okay?
Yes,
Or
ma'am.
we
Fine.
And for y, it would be 0 to infinity.
For
no for y it
x,
would be
for x, for y it is, if you are taking for y x by 2 to infinity, then for x it will be 0 to infinity. Okay? Fine. So let's just
Again,
integrate it.
it's are we using the x-axis to find the area or the y-axis?
Whatever you want, it's your choice.
Then can you explain it again?
Which one?
This question, x greater than 2y. This integration part. Why are taking two integration at the same time?
Okay. So this is what we say, two random variables distribution, right? So we need to integrate. So see, whenever the probability x greater than y or anything, let's say twice y, it is nothing but the double integral over fxy. Why it is so?
Product of margin.
Because it's the area of surface. So area of surface is given by double integral. Fine.
Yeah, okay.
Okay. So now you have to integrate, but now you need integration limits. So first you have integrated with respect to y. So just take any strip, consider any vertical strip. So you have considered this vertical strip. So this vertical strip starts with the point 0, where y is equal to 0. You have to check the values of y. When you consider the vertical strip, you have to find what are the values y is going to take at its lower point and at its higher point. Okay. So okay, so at lower point, your limit for like value for y is, yes, what it is x-axis. That means y is equal to 0, right? Along all this along this line, the value of y is going to be 0. But your upper limit is what? This slant line, x is equal to twice y. So if your strip it is here, then value will be what? Y is equal to x by 2. Now we move this strip from here to here or anywhere, the value of y will be x by 2. So whatever the value x is going to take, y will take accordingly. Okay. So in this way, I decided the limit for y is equal to 0 to x by 2. Fine. Now, once you integrate this part, let's, for example, this one, we have 0 to x by 2. Let's forget about this limit. So now, once you solve your this part, your answer will be in terms of x. And we have to find double integral. You have integrated with respect to y. Now, what about x? So, whenever we are trying to find out the limits for x, just check what the area, like where this strip is going to be swiped from 0 to infinity, right? From this part to infinity. To cover whole region, it has to swipe from left to right, right? So at leftmost, the value of x is what? 0. Why not negative infinity? Because we are we have to also consider the support of xy, that is x greater than 0 and y greater than 0. So the leftmost value is x is equal to 0 and rightmost value will be infinity, right? So that's why the limits for are 0 to infinity. Yeah.
How do we take that common region? How it taken?
Common region.
Ma'am, he's asking about the favorable region.
Favorable region. Were you there when we were discussing this kind of things?
Yeah, I got it, ma'am.
The same thing here. The same thing we are doing here. Because we know that when it's an exponential distribution, the required region is the whole first quadrant. Okay. So we are now interested to find out about this region only. Okay.
Ma'am.
Okay.
The favorable region above the line, if you take the favorable region above the line, what would be the limit of y?
x by t to infinity.
No, I mean x, the other way.
0 to infinity again. If you are taking this strip and you are considering this above area, okay, so area will be this one. So I just asked one question. If you have first you have created strip, now you just tell me to cover the whole upper area, from where to where you will swipe your strip, from leftmost to rightmost, right?
Yeah, yeah.
So that are the limits for your x. So what is the leftmost? Leftmost is 0, rightmost is infinity. So it's a
No,
0 to infinity.
can't we take the strip horizontally?
You can take, that is
Yeah,
also
so
fine. So
so it
if
would
you
be
take,
0 to 2, I know.
if you take, yeah, if you take 0 to, sorry, if you take it from, let's say for this particular example only, if you are taking it from the horizontal strip, let's me just change color. Okay, yeah. So the horizontal strip will be, let's say, like this,
Yeah, yes.
like this, right?
Yeah, yeah.
So what will be the, then this is the limit of what, x or y?
Y.
Okay. Then what will be the limits for x?
It would
So
be
the strip is horizontal. That means swiping will be from upper to lower or left to right. If your strip is
Here,
horizontal,
ma'am, here
like
we are
this,
just
see, I'm just telling you how to decide whether it will be a limit of x or y. Just check if this is strip means just consider it as a rod. Okay, the rod is placed horizontally. Now, how will you move this rod to cover the shaded region? Up or down or left to right?
left to right.
Is it fine? How will you like move this rod as left to right? You have to move it from lower to
Upper, yeah.
up to, yeah, because your strip is lying horizontally. Once this strip will reach to this point, this will become this, but actually you are moving this strip from downwards to upwards. So what are the limits when you are changing from down to upward? That is the limits of y. That means y will be in that case 0 to infinity. Okay, and the limits for x will be twice y to infinity. Okay,
Ma'am, we can take any one, okay? Isn't it?
what you can?
If you want to do the calculation, you can take either y or x, isn't it? Any one.
Y, x or y. Like either you take these limits or these limits. Yeah.
Yes, I am telling that only.
Yeah, yes, definitely. But the order of integration matters. Okay. When you take this these limits, you have to integrate first with respect to x, then with respect to y. Okay. This integration
Ma'am,
will
I have a
be,
doubt.
yeah.
Why isn't the limit? Why is the strip that we're taking? Why isn't it inside the favorable region?
Why? Can you please repeat?
Can this strip start from the y-axis?
Y-axis means this one here, from here.
Yeah, like
But
how it started for x-axis.
we are interested in finding this white area, right?
Oh, okay,
So
okay.
why
But in
we'll
this
look
case,
at this?
both will tend to infinity, right?
Yeah, yes, because it's an exponential distribution, right? So it will range from 0 to infinity.
Okay,
Okay.
ma'am. Okay.
Fine.
Ma'am,
So
can you explain this part? Means as this is dependent on, first we have to integrate the y part. No, here if we are considering the vertical this line, we have to integrate the first y. No.
yes.
Inner.
Yes. Because here, see, if you change the whatever the strip is, that should be first integrated. That's the rule. Okay. 0 to infinity. Yeah, what will be the, have you guys calculated this one? 3x by 2 by minus 3 minus, it will be minus minus plus 1 by 3. Fine. Dx. Is it fine?
Yes, ma'am.
Okay. Then, yeah, integrate it with respect to x. So let's just keep 1 by 3 outside. It will be 6 into minus 6 into e power minus twice x minus thrice x by 2 plus what? Sorry,
2, ma'am.
We can this keep this 6 also outside, right? Isn't it? We can keep it outside also. E power
Yes.
minus twice x. Okay. Dx. Yeah. The integral 0 to infinity. Fine. So it is what, 4 plus 3, 7 by 2. Right?
Yes, ma'am.
Minus 7 by 2x. This is e power minus 2x. Just integrate it. Yeah. It will be 2. Then integral will be e minus e power minus 7 by 2x divided by minus of 7 by 2 plus e to the power minus twice x division minus 2, and the limits are 0 to infinity. Okay. So what is e to the power negative infinity? Yeah, e to the power negative infinity. Do you know that?
0 or 1?
0, 0.
0.
What
Zero.
is this? What this answer is? 0 or 1? You decide, ma'am. Whatever you
0.
want. 2 by 7 plus. Yeah. What is it?
0.
0, 0, 0.
E raised to minus infinity equal to 0.
So this is the reason you should have knowledge of some standard graph. Yeah, it is 0. 2 by 7, yeah, e to the power negative infinity is 0, 0. Fine. So I can just directly take it as 0 minus, yeah, what will be there? 2 by 7 because e to the power 0.
2 by 7 minus 1 by
2.
2 by 7 minus 1 by 2. That's it, right? ठीक.
minus 3 by 14. 3 by 14. So it would be 3 by 7.
Yeah, 1 by 2 minus 2 by 7. Yeah. 7 minus 4, that means 3 divided by 14. So 3 by 7. Okay. So that was the probability that x is greater than twice y. Okay. So whenever the graph kind of things are there, we have to take a strip and vary it accordingly. Okay. So this was about joint density, marginal density, and how to calculate probabilities. So now there is one more term that is known as conditional probability. Have you heard that?
Yes, ma'am.
Yes.
You might be very well aware about this conditional density. What it is?
Ma'am, it's
f
joined
of
by
x y
marginal.
by fx.
Joined by marginal.
Okay, that is fine. If x and y are two random variables, then what is conditional density? That means one random variable has taken some particular values, and now what is the probability that another random variable is going to take some particular value? Let's say if I want to calculate what is the probability, what is the conditional probability that y is going to take a particular value y when x has taken value 1. This kind of things are known as conditional density. Fine.
Yes, ma'am.
And how do we solve it? So someone just told joint
Joined by
divided by
marginal.
marginal.
Joined by marginal.
Yeah, that is nothing but f of a comma y divided by what? Fx of a, right?
Yes.
Yeah, that's it. So this kind of things are there. Let's have one question based on that. So we were solving one question there. Or do you want another new? Let's take some another question. So if there is some random variables x and y such that their joint density is given to you is given x plus ky square, where x is ranging between 0 to 1 and y is ranging between 0 to 2. Okay, and 0 otherwise. Then just calculate what is the conditional probability that y is going to take value 1, given that x has already considered value 0.5. Will you be able to solve this question?
Yes, ma'am.
So what we have to do when to solve this kind of question? See, you have joint density and asking about the
First five marginal of x.
First, you have to find out k first
yeah.
by double integrating.
Double integrating
Whatever you
joint,
know, whatever you want. I'm
joint
just
density
waiting.
equates to 1.
Just tell me what's the conditional probability directly. Conditional density, okay? First, yeah, you told me to calculate the value of k. So what is the value of k here?
Ma'am, double integration with x and y is equal to 1.
Equal to 1. 0 to 1, 0 to 2.
Okay, I have not asked the procedure. Just give me the final point. The value of k.
Ma'am, k is 6 by 8.
Okay, just take it.
3 by 4 that is.
So calculation part, just if you will be wrong at k, that means the conditional will also be get wrong, right? Okay. So how to calculate the value of k? That means we know that this is the joint density and it has to be when integrated over x and y, it has to give 1, right? It's x is 0 to 1, y is 0 to 2, x plus ky square dx dy has to integrate to 1.
Is it 0? K equal to 0?
Okay, just confirm it. We are just starting to solve it.
I am also getting k equal to
So
0.
that is the value of k. Just calculate this conditional probability. That's it. Okay. So integrate 0 to 2 with respect to x means x square by 2 plus kxy square by 2, not 2. 0 to 1 dy. One by 2 plus ky square.
Actually, I got 3/16. Not sure if it is correct.
So it's just an integration part, right? So will not take that much time to recheck. See, I'm not revealing answer directly because in exam you will have to try by yourself, right? There will be no confirmation point at any point, right?
True.
So 1 by 2, that means 1 by 2y plus ky cube by 3, 0 to 2, which is equal to 1. Fine?
Yeah, ma'am. So it is 0.
Yeah. So it's 2 by 2 plus so yeah, it is 8 by 3k is equal to 1 minus 1.
4.
It is 0.
Yes, right. I got it right.
Now conditional probability Fy.
Here, ma'am, one thing I wanted to know that here we can do it in any order, whether I do go by dx
Yeah.
first or I go by dy first. I get the
Yes.
same answer for that.
The main thing is if you are applying the limit of x, integrate first with respect to x. If you are applying limits of y, integrate with respect to y. If you will change that order in the
No, no.
limit and integration terms, then it will be a disaster.
Because in the previous example, when we were integrating, so you said na, that you have to integrate by x first. Y first, sorry. When we had the limit of x by 2. Y
Yeah.
equal to x by 2.
So this limit, if limit of x is there, then integrate with respect to x first. Because this is connected to this one, this is connected to dy.
So, ma'am, in that case, we have to take y as a constant and solve for it.
Yes. Or if someone like the student has solved like that, and if you start with the integrating with y is equal to 0 to 2 x plus ky square
Yeah, I did that.
and
in
take
that
dy,
video.
and then we integrate with respect to x from 0 to 1 and dx. If you are maintaining these orders,
ma'am, this if we take this path, this answer is not matching actually. I got x square by 2
Mine-
plus.
from this
Mine-
part,
Yeah.
just take,
Yeah. So the integral of the first one is x square by 2 plus 8k by 3, and
it should not
It will
happen.
not be x
It
square
will
by
be
2.
No, xy. Respect to y. xy.
x square by 2 plus 8k by
Not
3.
like that. Not like that. xy. No.
Now you are, see, just a minute.
X is constant.
When you are integrating with respect to y, you have to keep x as a constant.
No, ma'am. I was
It is
telling
constant.
after integral what you will get. So after taking the integration with y, it is x plus ky cube by 3.
Just a minute. Just it will be x plus or
xy plus.
xy plus ky cube by 3.
xy plus ky cube by 3. xy plus ky cube by 3.
Why it is? Because x is constant, so you will keep x outside and integrate 1 with respect to 0 to 2 dy. Right? Again, k is constant, integral 0 to 2 y square dy. So I think you missed this part, that this will give you x, y.
Right.
Okay. So now check it if you want to. This is equal to 1 and integral 0 to 1. These are the limits of y. So twice x plus 8 by 3k dx is equal to 1. Yeah. Again, with respect to x, that means 2x squared plus 8 by 3 kx 0 to 1 is equal to 1. So yeah, again it will be 1 plus 8 by 3k, which is equal to 1. Again, k is equal to 0. Okay. So be careful with the integration. Otherwise, even though you are very clear with the concepts, but you'll lose your marks unnecessarily. So let's start with this conditional probability. How to calculate it? It is nothing but f of 0.5 comma 1, right? Joint probability at this point, fx at 0.5. So how to find this f 0.5 comma 1? for that we have this value, right? K is 0, that means fx of y
It
is
is
nothing but
0.5.
x. That is, yeah, it is 0.5 only. And what about fx of 0.5? That we have to calculate, right? So fx of x will be what? Integral?
Integration in range y.
Yeah, limits of y. What are the limits of y? 0 to 2. Is it? Yeah, the limits of y are 0 to 2. fxy dy. Fine. What are the fxy here? X only.
X.
So it is x into y 0 to 2. That is nothing but twice x. So fx of 0.5 we needed, right? That is 2 into 0.5, which is equal to 1. Fine. So this conditional probability is 0.5.
Yes, ma'am.
Okay. So that was all about joint density, marginal density, conditional density. Okay. So now if you guys have any doubts, then you can tell me. So what we did here, we started with x and y are two continuous random variables, right? Whenever there are two random variables, just check whether
That
what are the
last answer is 0.5 by 2x. That is what you
yes,
got.
yes, 2x, and just put x is equal to 0.5 here because we want marginal density of x at a point 0.5. Okay, that will give you 1. So if there are two continuous random variables, as there are two random variables, now we will talk about joint density of x and y. That means we denote it by like this, joint density. Okay, or some people denote it by like this also, fxy. How to calculate this? If it is uniform, then there are certain ways. If it is not, then you have to calculate some other ways. Okay. By using this joint density, you were able to find the probability of any region, any required region, right? For example, like x less than y greater than y, or some x greater than y by 5, or like that kind of things. You were able to calculate it. How do we use to calculate it? The standard one is to double. It was the, since it is two random variable, it is the area of the region, which is given as like integral over your joint density dx dy. These are the limits for x, these are the limits for y. For general term, we can write it negative infinity to positive infinity, because rest of the part will become 0 whenever fxy is 0 there. Okay, then after joint density, we calculated marginal density. From marginal density, we checked whether our whether the two random variable x and y are independent or not. Okay, so there are certain formulas for marginal density, like if we are dealing with the marginal density of x, it is nothing but the integral of joint density over the limits of y, and if it is y, then over the limits of x. Then after marginal density, there is one more term that is known as conditional density. That is what, whenever two random variables are there, and if we need to calculate values of x at a certain point x, given that y has taken already a value y, that is known as conditional density. We define it as joint density of xy upon marginal density of y. So in this way, these three are connected. If you know, if you are dealing with the two random variables, two or more random variables, in that case, if you know about these three things, then you might be able to know about whatever you want to know about that particular distribution of x and y. So this is the whole compact knowledge, if you know about the two continuous random variable, if you know about its joint density, marginal density, and conditional density, that's it. Now ask any question about this particular distribution, you will be able to find out each and everything regarding this. Okay.
Ma'am, in questions, either they will give joint density or they will say x and y are independent, right?
What? Please repeat.
No, we can expect questions like either they will give the joint density directly, or we have to find saying that the variables are independent.
Yes. Yeah. This kind of questions are definitely expected. Either, see, there are some standard formation that we learned today also, that uniform distribution, if x and y are following uniform distribution over certain region D, then you know how to calculate joint density, right? Or the another indirect question would be, you have given with the marginal densities and asked to find out the joint density, right? So, like that only.
Ma'am?
Yeah.
One example of a joint, to find joint density, if it is not uniform.
If it is?
Not uniform.
Okay. So, okay, fine. Give me a minute. You want an example that is non-uniform, right?
Yes, ma'am. As we can find D from joint, this uniform, and we can get this, but for it not being uniform, how can we find one example, such example?
Okay. If it's not uniform, then generally we will have its density function.
Okay, then density function will be given.
Yeah. Either thing.
And if it is uniform, then we can reach to density function by finding D.
Yeah. Yes. If it is not uniform, then how will you be able to calculate the joint density? So it might be like they will give you the joint density if it is not uniform.
Okay, then it will be given.
Yeah. Like this, it's see that x and y are two random variables. They are following this kind of distribution. Let's say, yeah. Then yeah.
I'm only confirming it being valid PDF and integrating is the.
Yeah. That's it. Okay. One more thing I have to clarify, that when you find these values of k, this kind of questions are there. And see, in this question, if you were wrong with this k value, then even if you know this, how to find this conditional probability, you will lose your marks, right? Because you will not get the answer because of this small mistake here. So how to check whether your value of k is correct or not? So whatever value you get for k, just put it in the given joint density.
Again,
and
integrated in the range, we should get 1.
Exactly.
Okay.
So that 2 minutes will save your marks, right? It will not, I don't think so it will take 2 minutes also.
Ma'am, I'm sorry, say that again, ma'am. If whatever value of k I get, I need to put in the equation.
And check that after putting that value, your integration is going to take value 1 or not.
Okay.
It has to take 1, right? Only then whatever your PDF is, whatever your
The
density
PDF is valid.
function is, yeah. Okay.
When you say integration, it is double integration, is it?
Yeah.
Okay.
I told you. See, just check whether your x and y both are continuous or not. So see, this quiz will be, I think, from week 5 to week 8, right? So there are two things are there. One is discrete and continuous. One is both continuous, right? So just be careful. If one of the random variable is discrete, then there will be a single integration, not a double, right? So be careful with that.
Ma'am, I have one question.
Sorry, ma'am. Before, ma'am, this week 5 to 8 or 1 to 8, ma'am?
Sorry.
This week portion is 5 to 8 or 1 to 8?
Yeah. 1 to 8 it seems. Yeah, the weightage will be more to 5 to 8, right?
Okay.
So I will clarify it and tell you.
Okay, thank you.
Okay. Yes, someone has raised hand. Abhishek.
Yes, ma'am. I actually have a question. Like in real life scenario, if I have a uniform distribution of customers, right? And there are some policy that are following exponential distribution. So in that scenario, how would I be able to find that these two variables are dependent or independent?
Okay. So this
Like I don't
dependency.
have anything given. Like I don't have anything like marginal or anything given, so that I can check by formulation. How can I get that information that these two probably have the dependence on each other?
Okay. So actually there are methods for it, but if you have the data, no, I'm considering you have data. So from data itself, you can make the relationship. Either there is something that whenever the values of exponential random, what you say, one is the exponential, one is uniform, right?
One is
Depending
exponential,
on the
one is uniform.
exponential, is there any
Probably
changes?
customers would be in a discrete distribution, and this exponential would be on continuous sort of.
Maybe.
As per belief.
But see, whenever it's a real life, there are lots of parameters, and we decide on that what to do or what not to, because there are lots of things. But as of now, whatever we studied till now, I would say just look at the data, and you will get to know that whether there is any relationship or not.
Okay.
Whenever we have real life data, the main thing we have, which gives us liberty about the data, is data itself.
Okay.
And you will
Excuse
learn
me,
more things about regarding these things in further lectures also. See, whatever we are studying in statistics is tools that you will use there. Right?
Data should always relate with any kind of distribution. If it doesn't match with any kind of distribution, we can't make inferences or a conclusion out of it.
Yeah, but see, these are some of the tools, but these are not the only tools. Okay, there are so many things. So just keep going on, keep going. You will learn more and more, and get to know how to do rest of the stuffs. Yes.
Ma'am, so week 7 is about the same thing only, right? Suppose I have a data about stock market, and one of the variable is the opening price of every day. So opening price is in points, so I can take it as continuous random variable, but I don't know the distribution of it, so I have to know about the distribution of it using the sample.
Week 7 is about sample things. So yeah, it's about sampling kind of things. Yeah, but that is just a start. What you said, that's more or less correct, but that week 7 is just a start of that thing. Now you will learn how to find out the estimation also and all these things in further lectures. Okay. So okay, do you have any doubts for this particular thing that we have discussed today? Anything related to that?
No, ma'am. Thank you.
Okay, thank you.
Thank you, ma'am.
Yeah.
Thank you, ma'am.